Okay, let's make some more clarifications. Someone may get confused. For example, we said on the dimension representation, speed is equal to meters per second, but we wrote this as meters. We wrote this as LT -1. Okay. All right. So when we are doing that, we said this is length, so we represent it by L, and this is time, we represent it by T. So this is how it goes. How did we arrive there? We can write this as meters over second, all right? Meters over second, there's no problem because this shows division. Remember, speed is equal to distance over time. So we are dividing time into length. This can also be written as meters per second. Okay, it's just one in the same thing. What this means is, remember the laws of indices. If this one goes up, it will carry a negative. If this one goes up, it will carry a negative. So if again we have got m over ac squared, this is the acceleration, right? This is can be written as that. So we need to be very much aware of that. That's how we are getting those. So let's look at them very, very critical. Okay. So that becomes written as meters per second. Okay. Therefore, meters is length time -1. Okay. Let's look at force. We looked at force. We said force is kg meter per second square. Now remember that this s is down here, so it can be written as kg multiplied by meter over ac squared. Are you seeing that one? Therefore, we can say kg is mass. This is meters length over time squared. Then this t can go up there. What does it becomes? It becomes m l t -2. That's how force was coming out there. All right. Let's look at another one. We can pick now this time around energy. Energy, which is the kg meter squared per second squared. Remember that this over shows a division, so this one can be expressed as kg meter squared, okay, just the same thing, or kg meter squared over s squared. It's just one and the same thing. Okay, so you should always know how to express this into like this or into like this, because when the equation is complex, you might want to express this as that. Okay, we'll see how it we'll take an example. So this being kg meter squared per second squared, kg is mass, length squared, t squared. That's how energy was coming out. All right, let's look at an example, okay, so that we speed up our understanding. All right, so let's say prove that volume is equal to energy over pressure. Prove that volume is the energy over pressure. Now remember, volume is that cubic meter. Energy NH is measured in joules, not so, and we said it is mL squared T squared over, remember what we did for pressure, mL -1 -2. Okay, so remember that this we have already expressed it, this side we have already expressed it in dimension form. This one is still in units. This is L to power 3 is equal to, so now remember, this might be difficult for you, but you might want it just to cancel direct here. If you can see it the way I'm seeing it, you just cancel this T, you cancel that T, you cancel this M, you cancel this M, then this one will go up and become +1, and it will be L to power 3. But let's take it in the simple way. We start with the top one, mL squared, remember this is over T squared, divide by that one, M over L multiplied by T squared. Okay, so L to the power 3 is equal to mL squared over T squared multiplied by, these will go up now. Okay, LT squared over M. So this M will cancel with that M. This T squared will cancel with T squared. So you are remaining with L squared times L, which gives you L to power 3. So L to power 3 is equal to L to power 3. So this actually proves that volume is equal to energy over pressure, or work over pressure. It's one and the same thing. So you should always know how to express units into their dimensions. For example, this is a unit, you express in its dimension. The energy, joules, we express in its dimension. Pressure, we express in its dimension. Then we cancel out and reduce to the simplest form.